The universe is huge and mysterious, and it keeps giving us new insights into its distant past, showing us things that make us think again about how it all began. Thanks to the amazing James Webb Space Telescope, JWST, astronomers have made another discovery. This time, it's about how galaxies formed in the early universe. The answer might surprise you. It's a phenomenon known as inside-out galaxy growth, and it's giving us a unique insight into how cosmic structures formed and evolved in the chaotic period following the Big Bang. So what exactly is meant by the term inside-out growth? Imagine a galaxy as a city that's growing. At the center, there's a dense core, a busy, crowded downtown area where most of the stars are concentrated. But just like a city starts to spread out into suburbs, so too does the galaxy. And in this case, the formation of stars, the cosmic equivalent of urban expansion, speeds up at the edges, spreading outward from the dense core. This process is what astronomers call inside-out growth, and it's something we've never been able to observe so early in the universe's history until now. The James Webb Space Telescope has enabled astronomers to look back in time to a period just 700 million years after the Big Bang. In cosmic terms, that's practically the blink of an eye. It was a time when the universe was still in its infancy, full of turbulent gas clouds, and the first galaxies were beginning to form. And what they saw was pretty amazing. A galaxy that's 100 times smaller than our Milky Way, but already looks pretty mature for its age. The galaxy's core was already dense with stars, while its outskirts were teeming with new star formation, spreading outward like ripples in a pond. This is a real game changer. This is the first time we've seen proof that some galaxies in the early universe didn't just grow by merging with other smaller galaxies, which is one way modern galaxies expand. Instead, they seem to pull in gas from their surroundings, using it to fuel new star formation in their outskirts, creating a sprawling galactic disk. It's as if this galaxy had already figured out a more efficient way to grow, even in those early chaotic days of the universe. But why is this so important? For years, astronomers have been trying to understand how galaxies evolve over billions of years. They want to know how these massive, complex structures, like the Milky Way, came to be from the small, dense clouds of gas that formed shortly after the Big Bang. Up until now, most of the data we've had about galaxy growth has come from studying galaxies that are relatively nearby, galaxies that are billions of years old and much closer to us in cosmic terms. The James Webb Space Telescope lets us look much further back in time, observing galaxies as they were in the first billion years of cosmic history. This is a whole new area of exploration for us in understanding how galaxies evolve. For example, the galaxies we can see today usually grow in two main ways. They either pull in gas from their surroundings, which collapses under gravity to form new stars, or they grow by merging with smaller galaxies, absorbing their stars and gas in the process. But what about galaxies in the early universe? Did they grow the same way, or were different mechanisms at work back then? That's the question astronomers are hoping to answer with these new observations from Webb. To grasp the importance of this discovery, let's take a closer look at what we know about galaxy formation. When galaxies first come into being, they start out as dense clouds of gas, which collapse under their own gravity. As the gas collapses, it forms stars, which in turn create the core of the galaxy, a bright, densely packed region of older stars at the center. As time goes by, the galaxy draws in more gas from its surroundings, which fuels more star formation and makes the galaxy bigger. You might be wondering how this process relates to the spinning figure skater analogy. It's a great way to understand what's going on as a galaxy grows. Think of a figure skater spinning on ice. When they pull their arms in close to their body, they spin faster. This is because pulling in their arms reduces the amount of space they take up, which increases their rotational speed. Galaxies work in a similar way. As they pull in gas from larger distances, this gas adds momentum, causing the galaxy to spin faster and form the spiral or disk shapes we see in galaxies like the Milky Way. The galaxy observed by Webb as part of the JWST Advanced Extragalactic Survey, actually doubling its stellar mass in the outskirts roughly every 10 million years, which is an incredibly fast pace compared to the Milky Way, which takes around 10 billion years to double its mass. This rapid growth suggests that the galaxy is rich in gas, which it's using to fuel its star formation. And this abundance of gas may tell us something important about the conditions in the early universe. In today's universe, gas is more spread out, and galaxies have to work harder to pull in enough gas to form new stars. But in the early universe, it seems that gas was more abundant, making it easier for galaxies like this one to grow quickly. What makes this discovery even more exciting is that it backs up what theoretical models of galaxy formation have been predicting. For years, astronomers have used computer simulations to model how galaxies grow based on what we know about the laws of physics and the behavior of gas and stars in the universe. These models suggested that galaxies should grow from the inside out, with star formation starting in the core and gradually spreading outward. But we didn't have the observational data to confirm these predictions until now. The James Webb Space Telescope will let us finally check our homework, so to speak, and see these processes unfolding in real galaxies. By looking at the light given off by the galaxy at different wavelengths, astronomers were able to work out how many young stars there are compared to older stars. This info, along with data on the galaxy's star formation rate and stellar mass, gives us a detailed picture of how the galaxy is evolving. The galaxy is so compact that the researchers had to use a technique called forward modeling to account for the effects of the telescope's instruments on the images. This involved using sophisticated models of how light interacts with gas and dust in the galaxy, allowing the researchers to separate the light from younger, actively forming stars in the outskirts from the older, more established stars in the core. The next thing we need to do is check if this inside-out growth pattern is common in other galaxies from the same time period. Was this galaxy a bit of a one-off, or were many early galaxies growing in a similar way? The researchers are now looking at data from other galaxies observed by Webb, with the aim of getting a better understanding of how galaxies evolved during the first billion years of cosmic history. If they can find similar patterns in other galaxies, it could completely change how we understand how galaxies like the Milky Way came to be. By comparing galaxies from different periods in cosmic history, astronomers may be able to reconstruct the entire life cycle of galaxies, from their humble beginnings as gas clouds to the massive complex structures we see today. Ultimately, this just goes to show how much there is still to learn about the universe. With each new observation made by the James Webb Space Telescope, we're getting closer to answering some of the biggest questions in astrophysics, like how the first galaxies formed, how did they grow and evolve, and what can we learn about the universe's past, present, and future from that? As we continue to explore the cosmos, it's clear that the James Webb Space Telescope will play a big part in rewriting the story of galaxy evolution. With each new discovery, we're not just learning more about the universe, we're learning more about our own place in it.